Okay, guys, welcome back. Let's see. I need to talk about program processing today. That basically is compilers and interpreters, but we need to finish with semantic analysis. The previous class, we review lexical and we review syntaxes. Hopefully you have the opportunity to review the examples that I show you and everything is clear. Any question about lexical or syntactical? No? Green?
I have a question.
Yeah, tell me.
When we say when the sentence only ends with delimiters, is that only like the semicolon, or does it include like the brackets and stuff?
Anyone. Could be the semicolon, an open curly bracket, or a closing curly bracket that is missing, closing parenthesis missing, anyone.
Yeah, but I was talking more about what's the full sentence. Is it only at the end of the semicolon, or does the sentence end when we open like the brackets?
Could you give me an example?
Yeah, I can type in. So it's like, let's say this. Is this only a one sentence, or does it end after the print all?
That is one sentence, full sentence. Now, the question is correct or not? And I will say, yes, is correct.
Yeah, I understand.
Because remember, we review sentence by sentence, so we do not care, for instance, that that line is not inside of a class or that we do not have the class there, because as a sentence, and we assume that the sentence is inside of a document, the document is going to have class or whatever, but that sentence is like, okay, modifier is optional, the public is void, and because it's void, the return is not mandatory. So having the curly brackets empty is fine, and the parentheses with nothing inside is fine. The name print all is correct. So as a sentence, everything fine. Good. The other example below, 13.12.32, that is one word, yes, because we do not have spaces, we do not have delimiters, we do not have operators. So all of that is one word. The next question is correct or not? And hopefully you tell me no, because we cannot have numbers and two dots. I mean, one dot is fine, it's going to be a floating point number, but when you put another dot, that is wrong. So that one, 13.12.32, is one word and is an incorrect word because do not represent anything that is valid. That is a lexical error. Yeah, of course. If you have 0xff, that is a word, and it's a correct word because represent an hexadecimal number. Good. So basically, one rule. Yeah, go ahead.
Does two equal signs count as one word or two?
One word.
One word. Thanks.
One important rule when you think about the two equals is the following. Always, 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 in any programming language, the compiler, that is the one doing the lexical, syntactical, and semantic analysis, always, always, always is going to try to create the longest word possible. So if you think about it, when I have the equal and another equal without a space between them, they are going to create one word, two together in one word. And that is possible because the two equals represent the comparison. So two equals together are going to be one word, one operator, instead of two operator assignment. And the same is going to happen with the lower or equal than, or the not equal, exclamation symbol equal, always, always, always. We're going to try to create the longest word possible. So two symbols are going to try to be one operator.
Okay.
Open and closing bracket count as different words. Yes, remember, open is one word, closing is another word. Doesn't matter that is the curly bracket, the parentheses, the square brackets, they are separate words. And when we create a sentence, that sentence should have, you know, the open and the closing. That is a syntactical thing. But any symbol, delimiter or operator is one word, including the parentheses. Two parentheses, two words. For instance, in the example that Dragan put before, how many words do we have there? Public, void, print all, parentheses, and curly brackets. Total number of words there. Hopefully you agree with me, 7. Yes? Good. So that is lexical, syntactical, and semantical. What you are going to do in 340, the next class, is to create a program that do lexical, syntactical, and semantical analysis, a compiler for a language that you are going to create. So that is the goal of that next class. Now, following with semantic. If we talk about semantic, quick announcement, there is going to be assignment 1 open today. Your assignment 1 is Java programming. You can start immediately because anything that you need to know is Java programming. So it's basically one assignment for me to evaluate your knowledge about CSI 110. So assignment 1 is open and you have this week to work on that. You're going to have a quiz 1 also open today, but my recommendation, wait until Thursday because you need some concepts from today and the beginning of the next lecture before starting with the quiz. The quiz is going to be open 1 week. So my recommendation is wait for Thursday and you can maybe do the quiz Thursday or Friday or during the weekend, but it's going to be open like today, the quiz and the assignment. So you have homework. Start working with this, is Java. Now, we reviewed this in the previous lecture, lexical and syntaxis. Hopefully you are experts on that. And we need to review semantic, meaning for the sentence. The meaning for the sentence, that one is going to be kind of easy. The only thing that I need to be sure is that we understand the difference between the semantic analysis, the meaning of the sentence, and the runtime errors or the runtime problems. The most common problem is to identify lexical and syntactical, but then the common mistake that we do is to believe that runtime errors are semantical problems. Let me be clear with this. Semantic is all about the meaning of the sentence on the paper. Semantic is all about the meaning of the sentence before running the sentence. When you run the sentence, the problem is something failed in the CPU. Two different things. Let me talk first about semantic, and then I give you some examples of runtime errors, and you're going to notice the difference. Now, semantic first, and then runtime errors. For the semantic or the meaning of a sentence in programming is going to be basically these 6 things. If we talk about semantic errors, the only possible options are these things. Semantic error number 1, we talked about this in the previous lecture, declaration of variables. If you do not have a data type for a variable, if you do not declare the variable, that is a semantic error because you are not going to be able to define if the types match because you do not know the type of a particular variable. So declaration of variables, first problem with semantic. Second problem with semantic. What happens if you create a variable 2 times? we agree that that is an error. You cannot declare a variable 2 times. You cannot give a variable x type int first and then try to create another variable with the same name in the same scope with a different type, because unicity is each variable in the same scope have one type. This is also a semantic error. Again, variable with the same name in the same scope. If you remember, I can do this if I put one variable local and the other global, and there is no problem. But if you try to put both local or both global, then you have an error. The error is a semantic error, a problem with the meaning. Good? Declaration of variables, unicity. Now, any problem with the types, anything with types, like we did before, an integer in which you try to store a string, classical example, or an int in which you try to store a floating point number. Even if I do not have decimals, but when I add the f, I am asking for a float. This is like 7.0, and I cannot store that in an integer variable. It's going to fail because the meaning of the sentence. I have a problem with the data types. It doesn't matter if you're trying to do an assignation. It doesn't matter if maybe you have a method that returns strings and you're trying to return a number, or the method return numbers and you're trying to return a string. Any place, returns, parameters, assignations, whatever you have in which the types that you are expecting and the ones that you are using do not match, you have a type problem, and that is a semantic problem, period, a semantic error. Now, when you use arrays, always, the semantic rule is the index for the array should be an integer number. So if I have an array, I can use something like this. The index is the number 5. You cannot make the index of an array a floating point number or a string or something crazy. It should be an integer number. Now, it should be an integer number, but it can be an integer number with any format. For instance, you ask about the hexadecimal numbers. You can use hexadecimal as an index for the array just because the hexadecimal is an integer number. Octals, hexadecimals, binaries. The ones that Java use, they do not have floating point part. They are integers. You can work with them like with any other. The index 15 is going to work. Good. Now, what happens if I have an array and in the array, I try to access the element 200, and maybe my array is only 5 elements. Let me be clear. The only thing that the semantic is going to review is that this one is an integer number. The semantic don't care about index out of bound exception. The exceptions are runtime errors, not semantic errors. Again, the semantic is only checking that this number is an integer. If the number is an integer, but is too big and the program crashed in runtime, that is not a semantic problem. That is a runtime problem. The semantic is fine if the number is an integer, period. Similar, when you have conditions, it could be the condition of an if, or it could be the condition in a while. Remember, the while loops have conditions. Even the for loop, the parameter in the middle is a condition. Any condition should be a Boolean value. that is also a semantical thing. For instance, in Java, if I put an if, open parentheses, and put something like hi there with the quotation, that is going to be an error. It's going to be an error because inside of the parentheses, I need to have a Boolean value or a Boolean expression. And what I have is a string that do not have a meaning. That is a semantic problem. The one that you have on the screen, array with a lot of nines, that is correct semantically because, again, array, brackets, and that one is an integer number. We are using an integer number as an index. That one is going to be a runtime problem because maybe that one, integer number, is too big in Java. In a different language like Lisp, that one is fine. Moreover, that one, maybe I do not have enough elements in the array. It's going to be a problem. Runtime is going to crash, but semantically is fine. Semantically have a meaning. I am trying to access the element 9999999 in an array. It have a meaning. The computer cannot accomplish that goal. It's a runtime problem in the computer, not a semantic problem, because the sentence have a meaning. Runtime errors, semantic errors, two different things. Good? Conditions should be Boolean value. Here, be careful, because what is a Boolean value? In Java, a Boolean value is true, false. We're going to review another programming languages. In particular, I need to mention C and C++. In C and C++, a Boolean value is going to be 0 or 1. A Boolean value is going to be basically an integer number. It is fine. The language is going to define that. So in Java, something like this is a semantic error because this one is not Boolean, it's integer. But in C++, this line is going to be fine because the semantic for C and C++ establish that the one is a Boolean value. The one corresponds to the true. So we need to review the semantic of the language and need to check what is the meaning of Boolean in the particular language. This is a semantic error in Java. It's not going to be a semantic error in a different language. And that is going to be exactly the same with other things. The one that is in the chat, the array 99999, is going to be a runtime error in Java, but it's going to be perfectly fine in Lisp. Good. So return types, as I mentioned before, they need to match, and parameters, they need to match. So data types, declaration of variables, only one time, conditions, Boolean, and the index of an array, always integers. Those are the semantical rules or the things that the semantic consider for any language. Those are the things that can be semantic problems. So examples and working with Java. If I give you this code in your exam and I ask you for lexical errors or syntactical errors or semantical errors, you can tell me lexical errors, hopefully you agree, 0, all the words are fine. Syntactical errors, hopefully you can agree, 0, all the sentences are fine. And when I ask for semantic errors, you can point out the things in red. For instance, one variable n, a second variable n. It doesn't matter that they are the same type, but they are twice. There is no unicity here. You cannot have variables with the same name twice, in this case, local. Remember, parameters are local variables. So case 1 have an error and is semantic, and the reason is unicity. In the second example, no parameters, but locals. If I put int the type before each name of the variable, I want to have twice this one, is an error, no lexical, no syntactical, but semantical. Again, unicity. Another example, if I give you something like this, and again, the question is problems with lexical things or syntactical things or semantical things. Hopefully you agree with me, everything is correct in terms of lexical. All the words there are fine. Everything is correct in terms of syntaxis. We have 3 sentences. I know that there are 3 sentences because the semicolon ends a sentence. Well, you can count 4 if you count also the comment, and the comment is a full line. Everything fine with lexical and syntactical, but semantic, we have problems. Int, hello, char, false, boolean, C, that is a char. These two do not match. Semantic errors. Similar, I can give you in your exam any example like this one or the previous one or a full program, and the questions are going to be lexical, syntactical, or semantic problems. Identify them and check, multiple choice usually, check the type of error. Yes, all of this is semantic error 1, this is semantic error 2, this is semantic error 3. 3 examples of semantic errors, 3 sentences. Each sentence you check for semantic, and all of them, the problem is the type matching. These do not match with integers. Hello and integer do not match. False and char do not match in Java. And the C is char, and the char do not match with boolean in Java. Again, all of this is assuming that you know Java. All of this is with the Java background. All of this is using the rules for the Java language. Those rules are going to change a little bit in the next languages, in particular with C and C++. Good? Okay, so that is semantic. And as I mentioned before, semantic is not runtime error. So classical question in your midterm, classical question in your final exam, Java, int, x equal 1, division, 0, semicolon. There are errors there, yes or no? Let me be more specific. There is a lexical error there, or a syntactical error, or a semantical error. Lexical, syntactical, or semantical? And hopefully the answer is no. Everything is correct in lexical. All the words are correct. The sentence is correct. No syntactic errors. Moreover, the meaning is correct. There are no semantic errors. Again, because if you tell me that there is a semantic error, the error should be any of the 6 that I mentioned before. Declaration of variables, unicity, type matching, conditions, arrays. There is no problem there. We have the division of 2 integers. 1 is an integer, 0 is an integer. Integer divided by integer usually give you an integer. Oh, but this is going to be a problem. Yeah, it's a problem, but it's a runtime problem. Why is a runtime problem? Well, this is going to be something like that. The computer cannot handle this. It's a problem in the runtime. Not lexical, not syntactical, not semantical, runtime problem. is one of the things here. Okay, that is the question that I want to ask you, like runtime errors in Java. Do you remember what is the name for the runtime errors in Java? There is one fancy name for them. Runtime errors. Yeah. So if you ask me about examples, the only thing that I need to tell you is anything that you remember in Java with the name exception is a runtime error. Index out of bound exception, using an integer like my array, and the example that you give me, lexical, good, syntactical, good, semantical, good, maybe it's going to be exception if I do not have an array with this size. How do I know that it's going to be a runtime error? Well, because the error is going to be index out of bound exception, for instance. I think divided by 0, you can remember, you can try in Java. It's another thing that you have an exception, divided by 0, and more. Null pointer exception, when you are trying to use an object without initialize the object. And we are going to review more. Your homework is a little bit related with that. Runtime errors in Java, exceptions. Obviously, we do not have exceptions in all the languages. We have exceptions in Java because the virtual machine, but we need to review what is going to happen in other languages in which you do not have a virtual machine. But for Java, for the things that you already know, your exceptions are this category here. Any exception is not semantic error, is not syntactical error, is not a lexical error. If that is an exception, is a runtime error, and runtime error is another category different from all of this. And to be clear, all of these are the compiler work. You detect the lexical error, the syntactical error, or the semantic error because you are using a compiler. All of these are going to be a message from the compiler. For these ones, you're going to notice the runtime error when you run your program, not when you compile your program, right? Good. So, review this. A lot of questions in your exam related with those things. Exceptions in Java, correct answer, D. Exceptions in Java are runtime errors, I mentioned before. Now, examples, questions in your exam. If there is an error, yes or no? And if yes, give me the type of the error. Question number 1, question A. There is an error, yes or no? Here, there is an error, yes or no? Here, here. A, yes, no, to start that. Green or red? No, okay, so in the chat, no error, so that is fine. Good. This one, error? Error, this is wrong. Lexical, syntactical, or semantical? Okay, syntaxis or semantic? Syntaxis. Why syntaxis? This word is correct. It's the same word that before is correct. is a word is correct, is a word is correct, this word is correct, all the words are correct, no lexical problems. However, the sentence, I have a type, and what I am expecting after a type, another type, I cannot have twice a type, right? I cannot have a type and then another type here. There is a problem. There is a problem because I have correct words, but in the wrong position. The sentence is not correct. And if the sentence is not correct, because there are words in the incorrect place, what I have is a syntactical error, a problem with the syntaxes. Yeah, remember, you cannot have a name of a variable that match a keyword, a reserved word. So you cannot have a name for a variable that is int or byte or short or long because they are the name of the data types. In the same way, you cannot have a variable that is if, lowercase, or for, or while, because they are reserved words. So in this case, type, error. What about the C? Really? Is correct? And the answer is yes. String, data type, uppercase S. The lowercase is the name of a variable, it's lowercase. And this is a value because it's in the quotation marks, and I have the equal and the semicolon. Everything fine. What about the last one? D. Error, why? This one is an error, is a syntax error. However, if I do int y equal y plus 1 semicolon, that is similar to this one. That second one is correct or not? Like my line E. That one is good, right? Type, name of the variable, operator, name of a variable. What is going to happen with 3 pluses? Well, as I mentioned before, we try to put together the longest word, and the longest word is going to be 2 pluses together. Remember the increment operator. This one is the plus, and remember the operators are the limiters. So you can have together minus, pluses, multiplication, and so on. They cut the sentence. This is one operator, this is one value, and this is the semicolon. So basically you have integer y equal to the increment of y, and that plus 1. I do not know why you want to write something like that, but my point is lexical correct, syntactical correct, and even semantically is correct, and no runtime errors. The E. The D fails because the sentence is not complete. Something is missing at the beginning. You cannot have a sentence with an expression and nothing in the left part. Good? Again, always the longest word. So this is one thing, this is one thing, and if you put more, well, that is the order. The two together first, and then the plus that go along. Fine? Good. Next step. As I mentioned before, lexical, syntactical, and semantical is going to happen in the compiler. Well, that if you have a compiler. Because the problem is, you know what? In order to process a program, there are 3 options. Option number one, you have a compiler and you have a virtual machine. Virtual machine is a fancy name for an interpreter. Which language that you know have a compiler and also a virtual machine? Java. Why do we have a compiler and a virtual machine in Java? Well, because the compiler is the one that is going to review the program and translate the program. It's going to review the lexical, syntactical, and semantical part of the program. Do you remember that in 110? And it's going to translate to a low-level language, in this case, the bytecode. And then the virtual machine is the one that is going to be able to execute the bytecode. The reason because you have the virtual machine is because that key idea of portability in Java, remember? You do a Java program, you compile your program, you have your bytecodes, and then if you have a virtual machine for Java in your computer, Windows or Mac, or even in your phone, if your phone have a Java virtual machine, then you can run your Java program in that device because the virtual machine is the one that executes the program. The virtual machine gives you portability. So Java have both a virtual machine and a compiler. The virtual machine for portability, the compiler for doing what we described before, lexical, syntactical, semantical, and the translation. That is something that you review in 110, CSI 110. Now, there are going to be languages that we are going to review that only have a compiler, no virtual machine, no interpreter. And there are going to be languages that we're going to review that do not have compiler, only an interpreter, only the equivalent of a virtual machine. So you know one that have both, and now we're going to review examples that only the virtual machine or only the compiler. And we're going to review advantage and disadvantage, but hopefully you agree with the following. Languages that are going to have only virtual machine, only interpreter. Those are going to be Lisp and Prolog, the last two that we're going to review. Lisp and Prolog do not have a compiler. You are not going to compile your programs in Lisp and Prolog. In Lisp and Prolog, the only thing that you're going to have is an interpreter, and with the interpreter, the virtual machine, you go and run your program. The advantage and disadvantage of having an interpreter. Guys, do we understand the difference between interpreter and translator? Because the compiler is the one that translates. Compiler is a fancy name for computers, but really what is happening is this translation thing. What is the difference if we talk about humans between an interpreter, a human being that do interpretation, and someone that do translation?
With humans, I think an interpreter focuses in spoken speech while translators in written. Yes,
that is the point. What happened with the interpreter? The interpreter, if we have an interpreter here in this class, I am speaking right now and someone is in the runtime doing the translation. Yes or no? There is no document involved. Line by line or sentence by sentence, when I am speaking, someone is doing interpretation. When you have two people talking, what you have between them is an interpreter. Yes, that is the name that you give to the human being that is there translating the conversation in real time. Interpreter, real time is a key idea. The other key idea is sentence by sentence. What is the meaning of that? Lisp and Prolog. You are going to write one line in your program, one line, and that line is going to be translated and executed. Another line, translated and executed. Line by line, your program is running at the same time that you're writing, because what you have are interpreters. That is exactly the same thing that do the Java virtual machine. But the virtual machine receive the bytecode and then run the bytecode. It's like receiving all the speech in one big file, your class file. But interpretation is about runtime, line by line. That is going to happen with Lisp and Prolog. Line by line, runtime. Hopefully you agree with this idea that in computer science, when you use an interpreter, that is going to be slow compared with using a compiler. Slow, why? Why slow? It's slow because you have the computer here and you have someone here that is doing the interpretation. This is the program. This is the computer. The computer is not running the program directly. There is someone in the middle, and that someone is the interpreter. This is going to make it slow. Think about you talking with another person. If the both of you talk the same language, the conversation is going to be much faster than if you have someone in the middle doing the translation in order to be able to, for those two people to communicate. Interpreters are slow. And yes, it's a synchronous thing. Line by line, read, understand, and run. Slow. Obviously, this is a program, the interpreter, like the virtual machine, is not only slow, but also need memory, more memory, because you have this guy there. Anyway, the good news is you can do programming quicker. Why? Every single line that you create, you put the line and the line is running. If you have an error, you're going to notice immediately. Instead of creating like 2-3 classes with 2-3 methods and then go compile and run. Well, you are compiling and running your program several times, right? You never finish the program and run at the end. Well, interpreter, synchronous translation, line by line. It's slow, but line by line, you are compiling and running, compiling and running. Lisp and Prolog. If you want to start working with them, for Lisp, you have two options that I am going to recommend you to use. Number one, you can go here and download the interpreter for Lisp. The interpreter for Lisp is going to look like this. It uses a console, nothing fancy. Remember, it's a programming language for the 70s, right? So do not expect anything great in terms of the interface. Option number one for Lisp. Option number two, exactly the same one, is available online. Online, you have this web page. This is the URL for the web page. And basically the web page is 2 columns. You write your program here, Lisp instructions, and you receive a result here. So you have 2 columns. Column number one is an editor for you to write your lines. You press the enter, move to the next line, and you have a second column. And in your second column, you are going to receive the result of your lines when you run them. Lisp interpreter. Install one in your computer or review the online one, whatever. The good news is you can do your homework for Lisp in your phone. If you connect to the URL, you can finish your homework in your phone and complete everything, copy, paste, submit. For Prolog, it's exactly the same. Prolog do not have a compiler, so you do not have a fancy environment. The only thing that you need is the virtual machine. You can get a virtual machine here. It's not the only one, but it's one that you can use for free. Again, it's a console. You have a prompt there, and you can start writing your program there, press enter, and the virtual machine is going to show you the result. Also, you have the option to use the same interpreter online, a web page, and similar to the previous one, you have a column here to create your program. In particular for Prolog, something that we're going to talk about it is the program is two different parts. One part for the action, one part for the information. So you put the information here, you put the actions here. So these two are your program. And when you run your program, the results, the output is going to be here in the web page. Again, it's an interpreter. You can use the web page, or you can install this one for your computer, or you can search for others. There are a lot of free interpreters. Also, this one from the 60s, so do not expect any fancy thing, at least in the one that you can install in your computer. The web is a little bit more fancy. Interpreters, Prolog and Lisp. Moving forward.
Excuse me, can I ask a question?
Yeah, please.
Can you get back to the interpreters versus compilers? I'm not sure. You said that the interpreter is slower than the compiler.
Yes.
Doesn't the compiler do the same thing, like translates the code and everything?
No, be careful with this. Two different things. If we talk about the interpreter and the compiler, the slow one is not the compiler on the interpreter. The slow is the execution of the program in the computer. How fast a program is going to run on the computer. The slow one is your program running in the computer. In this case, when you use an interpreter, this program is going to run slow in this computer because this interpreter is in the middle of the process during the full process. Like, again, two people talking, and because those two people do not talk the same language, we always have someone in the middle. And this someone in the middle, our interpreter, is helping us to understand each other. That conversation is going to be slow. That is what is going to be slow. When you have a compiler, and that is the one that I want to explain here, but going ahead, when you have a compiler, what you have is a translator. What is the difference between the interpreter and the translator? Well, the interpreter is listening to the information and in runtime, giving you a result. When you have a translator, what you have is something like the person that translates a book from one language to another. A translator is someone that is going to receive a file, like a file with a program, and is going to give you another file, like the compiler of Java receive a file with .java information and give you a file with bytecode information. What happens if I have a compiler, and it's going to be the case here, and that compiler receive a file with the program, all the program in Java or C++, that are the examples that I'm going to use here, and the compiler give you another file with exactly the same instructions, but in another language. For instance, in machine language. This file is something that I can give to this computer, and I do not have this interpreter in the middle anymore. It's like instead of listening to one person speaking in a foreign language, what you get is to go and buy a book in English that is the translation of an original book in a foreign language. For you, at the end, is going to be reading English. So that is going to be faster reading a book in English, even though the original source is in a different language, than having a person talking in the foreign language and having in the middle of the conversation an interpreter in real time translating for you line by line what the other person is speaking in the foreign language. The second one is faster than the first one. Makes sense?
Yeah, I understand. Thank you.
Okay. Yeah, thank you, Jacob. So every single time that you want something to happen faster in your computer, you use compilers, not interpreters. And you know what? Two very important languages that do not use interpreters but use compilers are C and C++. The operating system in your computer, Windows or Mac, is not done in Java. It's C and C++. A video game, not a trivial low performance video game, but think about a video game in which you need high performance, PlayStation, Xbox, whatever. C and C++. High performance computing, GPU programming, C and C++. Anything in which you need high performance, what you're going to have is your program in C or C++, usually, and then a compiler that is going to translate C and C++ to machine language. And when you run the program is running from machine language into the computer. No interpretation in the middle, no virtual machine in the middle. That is going to be what we are going to have with those two languages. And we need to review the power of that, but also the concerns on that. Having direct access to machine language is going to be a lot of power and, well, responsibilities there. Unity, if you think about it, the platform, the framework, have a lot of programming, even though, I mean, depending on what you're doing, but sometimes you are just creating the models, drag and drop things. But the programming, the platform itself, it's C and C++, and sometimes you can add some programming. I think you can even work with C#. That is another flavor of the same combination of C family languages. Bad news, when you use only the compiler, as I mentioned before in the example, well, you have your book and you do the translation of the book to a particular language, in this case, machine language. But if you translate your book to machine language for the PC, that book is not going to be able to run in a Mac computer. So in this scenario, you can think about Microsoft Office, for instance. You can have the source code of Microsoft Office in C, C++, but then when you compile Microsoft Office for a Windows machine, you have the product, the machine language code of Office that is ready to run in your PC, but that software do not run in your Mac. So you need to compile a version of the same source code, almost the same, for a Mac. Makes sense. You need to compile with two different compilers, one for PC, one for the Mac, just because you are going to translate to machine language, but the machine language of the PC and the machine language of the Mac are different. So it's like having a book in one language and translate that book in two different languages. And then you go and can buy the translation to, I don't know, Chinese, or the translation to Japanese, or the translation to Portuguese, or whatever, but there are different translations of the same book. You get the correct one for you, you get the one that corresponds to the language that you speak, and you're going to be able to read the book quickly without having a person there reading for you. Compiler versus interpreter. Now, For C and C++, you're going to need a compiler. That compiler, something that I need you to remember because we're going to review this in detail. Number one, you're going to start with a source program. The first thing that is going to happen is the compiler is going to read the source program. What is the first thing that you do when you want to translate a book from a language that you speak to a different one that you already know? The first thing that you do, and is the work of the compiler, is the lexical, syntactical, and semantical review. The compiler is the one that is going to do lexical, syntactical, and semantical review of the program. After that, always, 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 a compiler is going to translate the original program to assembly language. Do you remember assembly and machine? A compiler is going to translate first to assembly. Hopefully you remember the example that I showed you in the lecture 2, remember? A number plus a number. And hopefully you remember how easy it was to translate to assembly. And then from assembly, you do a replace all to binary. Exactly the same process is the one that a compiler is going to do. First, the program to assembly. Now, after that, inside of the same environment, you have an assembler. The compiler is going to receive the help of an assembler, and that assembler is the one that is going to translate from the assembly language to machine. To machine, I mean to binary. Now, do you remember that in Java you can have multiple classes in a program? Your program can be not only one file, but multiple files. The same is going to happen here. When you have a program and your program is multiple files, each of those files is going to be compiled. So each file is going to be reviewed lexical, syntactical, and semantical. All the sentences in each files are going to happen for that. Each file is going to be translated to assembly, and each file from assembly is going to be translated to machine language. So if you have a program that is 3 classes, what you're going to have here is 3 files now with binary information. The last thing that needs to happen is those 3 files need to become one. And that is a process that we know as linking. And the program that do that, put things together, is the linker. When we start working with C and C++, you are going to receive errors for the lexical, syntactical, and semantical part. And I need you to remember this word. Linking error is a problem that you're going to have working with C and C++, and it's going to be something is wrong when I try to connect all the files to create one program. So just remember, compiler, assembler, and linker. That is what is going to happen in the programming languages that use only the compiler. The compiler is going to be working in these 3 different steps. Compiling, that usually is lexical, syntactical, and semantical analysis. Then translate to assembler, assembler to binary, and finally all the binary files put together, and that is linking. Obviously, if you use a compiler, the main advantage is faster. Running the program is faster, not the compiler itself. Running the program is going to be faster. The usually issue that you have with compilers is you need to work a lot. You need to debug a lot before being able to show a result. Think about it. The interpreter is running line by line. So each line that you put there is going to run after you press enter. Here, you know from Java, you need to write a lot of things. And after you finish writing a lot of things, you can start trying to run your program and hopefully, finger crossed, run. So when you finish, it's going to be faster. The process of building the program, we're going to see what happened, but it's going to be a little bit slow, the programming part, the debugging part. For working with C and C++, a lot of you, maybe you want to work with Visual Studio, Microsoft Visual Studio. It is good. If you have experience with that IDE, if you want to learn how to use the IDE, it is fine. It is not mandatory. I am okay with you working with that, but it's not the only option. It's a very good option. However, you have other options. Other options, if you are already working with Eclipse in Java, if you are already working with some IntelliJ compiler, if you are already working with NetBeans, almost all the IDEs that you use with Java have the possibility to be extended to work with C and C++. My advice, review the IDE that you already know. If you have, obviously, if you have a Mac, you can work with Xcode. If you already have knowledge of a particular IDE, it is highly probable that you can continue using that IDE for C and C++, or if you have time to learn Visual Studio and you have interest on that, go ahead. But again, it is not mandatory to learn Visual Studio. Other options, there is an online compiler for C++. As I mentioned before with Lisp and Prolog, you can go open a web page, and in the web page, you can work with C++. It's very easy because you do not need to install anything. However, you do not have the support of a good IDE, right? All the fancy things. And there is also this very simple environment. We use the run compile options. Again, a lot of options. You can use whatever you want. We are not going to use any of the plugins. In fact, one of the things that I want to recommend you, if you have experience using IDEs, if you have experience working with this guy, it's okay. You can continue working with that. But if you do not have experience with IDEs, if you are going to use 10 hours per week, do not use your 10 hours trying to figure out all the fancy options that you have in the IDE. Usually my example is the following. In this class, the goal is to learn the language. The language. If I am here teaching you Spanish, French, German, I don't care if you use Microsoft Word to do your homework. Yeah, it's very fancy to use Microsoft Word to submit your papers. There is a lot of things there. Italic, bold, fancy fonts. But our goal here is not to teach you how to use Microsoft Word. The goal here is for you to learn the language. So if you submit your homeworks on paper, that could be okay. Here, you cannot submit on paper, but any IDE that you use without any fancy plugin for this class is fine. You want to learn the fancy plugins? Go ahead. Just be sure that you do not use your 10 hours per week learning how to use a fancy IDE. Learn the language. Later, you are going to have the opportunity to learn the fancy options in several different IDEs, depending on what you are doing in the future classes. Good? So, no plugins for this class. We do not need any plugin here. Make sense? Okay, so only interpreter, only compiler, and then we have these options. We choose both. In particular, we have two things. We have Java, and in Java, you have this compiler plus interpreter. Again, the interpreter is the Java virtual machine. And you notice what happened with Java. You have the compiler, therefore you compile your program. The compiler do not compile to assembly, but compile to bytecode. That is the equivalent of the assembly for Java. And then you never translate to binary, because in that point you put the virtual machine, and the virtual machine is the one that finally executes your program. The good news is the compiler is reviewing lexical, syntactical, and semantical, right? Do you think that the virtual machine review lexical, syntactical, and semantical again? Yes or no? No. Okay, why not? Think about it. You have a compiler, the compiler did the review, and the compiler is the one that creates the Java bytecode. The virtual machine knows that the bytecode comes from a compiler, and the virtual machine trusts in the compiler. The virtual machine is not going to review lexical, syntactical, and semantical, because the virtual machine knows that the bytecode was created by a program in the computer. And the programs in the computer do not make mistakes. The only reason, because we have lexical, syntactical, and semantical analysis, is because we need to review what a human being creates. Human beings make mistakes. Sorry. So anyway, compiler plus interpreter, only the interpreter, only the compiler, and there is another option. Compiler plus compiler. Compiler plus compiler, really. Do you know the .NET in Microsoft platform? .NET at the beginning was kind of the Microsoft equivalent to Java, the opportunity to compete with the portability of Java, at least the beginning. After that, several different things happen. But the .NET platform is an example of using two-step compilation. A compiler and then another compiler. Two-step compilation, the .NET. Classical example for the .NET, C#, but you know, there are a lot of languages in the .NET platform. What is the idea for the .NET platform? The following. In the .NET platform, you have a version of Prolog, you have C#, but also you have C++ and C. You have F# even, and there are more. The X is used, whatever, accommodating. In the .NET platform, the idea is the following. You have compilers for those languages. You know, the compiler, the one that is going to review lexical, syntactical, and semantical, and then translate. You have compilers for all of those. By the way, if you review the Visual Studio, you have available Visual Studio options for working with any of those languages. The compiler is going to do that review with these languages, and then it's going to translate to this language. That one is not assembly language. That one is not machine language. That one is the equivalent of the Java bytecode. And the name for that one, can you help me? What could be the meaning of those letters? Just guessing. It's Microsoft.NET. So thank you. Yeah. Microsoft Intermediate Language. Microsoft. Intermediate language, yeah, is between the language that is the original one, and whatever you want to use as a low-level language, something in the middle. The idea is any language that you want, I give you a compiler. That compiler is going to translate to this intermediate language. And then I have another compiler. And that compiler can translate to machine, well, or to assembly, just like the others before. Moreover, if you want, I can give you an interpreter here. It's going to be like Java. Yeah, it's going to be like Java. A compiler, an interpreter. I am not going to call this virtual machine of Java or missile virtual machine. I am going to use a different fancy name just to, avoid problems. And this is going to be called Git compiler, Git just in time. Do you remember why the virtual machine is slow? The virtual machine is slow because someone is speaking, the virtual machine is translating runtime line by line. The idea that this Git proposed is the following. I am speaking in a foreign language, and instead of the interpreter translate line by line to the other person, that interpreter is going to wait for me to complete my speech 1 hour. And when I complete my speech, the interpreter is going to give to the other person a translation of my speech. It was not line by line. It was not real time. It was more like the same thing that a translator do. Receive the book, translate the book, deliver a book. This Git is going to wait for me to complete my speech, translate everything, and deliver a book. Running the book is going to be as fast as using a compiler, because finally the computer is going to be running the book, not my speech, but the computer is going to wait until I finish with my speech. In this case, until this second compiler listen to the original code, read everything, do a translation in runtime, and deliver the bytecode, the machine language for the program, and then this can run in the compiler. Again, even though it's an interpreter, it's going to deliver a full translation. It's going to deliver the same result that a compiler, machine language. And that means that the computer running this at the end is running a full machine language version of whatever missile code or whatever language was used originally to create that piece of software. Drawback, like what? Everything looks like so perfect, right? The main thing is, remember, this is .NET. Do you remember what is the main problem with the .NET? Have you reviewed your Windows computer and noticed how many .NET things you have there? The problem with the .NET is twice the problem of the Java virtual machine. You need the Java virtual machine in order to run Java programs. You need the .NET platform in order to make this work. And you can check the space for the .NET. Yeah, now we have the .NET for other platforms. My point is, check the size, even in Windows. What is the size? how many of the space that the operating system is using in your computer is connected with the .NET? Now, to be honest, I mean, how many gigabytes you have in your disk? It doesn't matter the size of the .NET. At the end, you have a space, right? Today, we have the hardware for that. Well, at least in a computer. Problems similar to Java, the space. Problems similar to Java, this idea of having a full platform set up. Good thing, usually the platform is there with any window installation. So basically, if you have a PC, basically if you're running Windows, this is almost transparent for you. You have access to all of this, and they work perfectly. You can work on set up something like this in another platforms, but that is a different story. My point basically is you have the powerful of a virtual machine, still slow compared with the compiler only option. Slow because at the end you need to wait at least the first time to have the matching code. It's like the first time I am listening to the code that I do not understand, I need to translate to binary. The first time is going to be waiting. It's like when you run a video game and you're waiting for everything to load, but when everything is loaded, in this case, when everything is translated, the execution is going to be faster. So slow in that way when you wait for the compilation to happen. Portability, just like with Java. So as a summary, slow, but running line by line. Fast, but you need to complete a program first. And this is lexical, syntactical, and semantical analysis, translation to assembly, translation to binary. And you have combinations. Java, portability is kind of easy to run in any system. It uses the compiler in one computer for the developer, and then the user have the virtual machine. It's kind of good, easy. And then other solutions like this one, 2x compilation, in particular, Microsoft Intermediate Language, the philosophy of the .NET platform. And that's it, 11:50. Any question to close this? Nothing? Good? Okay, see you next lecture, guys. Thank you.